Hello, and welcome to 2024's first Future Car episode. It's been a while, so we're starting off with a bang, and I'll be sitting down with the technical director at Red Bull Advanced Technologies, Rob Gray. We talk a lot about racing on this podcast, and one recurring topic within the world of racing is the transfer of technology from race cars to commercial vehicles. From carbon fiber to anti-lock brakes and even the rear view mirror, we have the world of racing to thank for many aspects of our cars we ride in today. Red Bull Advanced Technologies is leading the charge when it comes to applying race car tech to commercial vehicles and even beyond. Rob brings 20 years of design experience from Formula One to his role as technical director at Red Bull Advanced Technologies, where they take the tech, the methods, and tools used to make a winning Formula One team and apply those to engineering challenges on land, sea, and air. In part one of two, Rob and I discuss his past professional experience in F1 and how it compares to what he does now. We also talk about the biggest technological breakthroughs he witnessed while working in Formula One and finish our conversation on the RB17, Red Bull Advanced Technologies' first hypercar project. We even throw in a bit on designing an America's Cup racing boat. I know you'll really enjoy my conversation with Rob Gray. We're all familiar with the Oracle Red Bull Racing Formula One team. They just won both the Drivers' and the Constructors' Championship, something they've done many times before. But the Red Bull Technology Group has several different organizations within it. One of them is Red Bull Powertrains. They're working together with Ford to develop a power unit that's going to comply to the new regulations that are going to come in 2026. And then there's Red Bull Advanced Technologies. That's who we're going to focus on today. Red Bull Advanced Technologies takes the technology, the methods, the tools that are used to make a winning Formula One team, and they apply those to engineering challenges that are on land, sea, and air. And this could be anything from a hypercar, a commercial hypercar, to a hydrogen-powered race car, or a bike, a balloon, submarine, a sailboat. And to explain all this to us today, we have just the right person, the technical director for Red Bull Advanced Technologies, Rob Gray. Rob, welcome to our podcast.
Thank you very much.
I want to read the description of Red Bull Advanced Technologies. It says, a company that brings exceptional engineering, design, and production capabilities to a diverse set of industries across land, sea, and air. Now, that description opens up a world of possibilities. It could be almost anything. So what is it exactly that Red Bull Advanced Technologies does?
Well, I thought your introduction kind of started to cover it quite well, to be honest. So really, Red Bull Advanced Technologies is a smaller version of all of the engineering and manufacturing side of the Formula One team. And so we take the technology that's used to develop the race-winning cars, and we apply it to a range of other industries, as you say. So we've got two core aspects of the business. We've got like the engineering side, and then we've got the supply chain side. The engineering side has all of the main departments that you'd recognize from the F1 team, but on a smaller scale. So we've got an aerodynamics department, we have a performance and simulation department, electronics, design, composites, structures, try not to forget any. And so we can put all of the engineering that we use on the cars, we can apply to whatever other project we want. We've then got the supply chain side, so we're building that up at the moment, and that's focusing on how we actually deliver the physical components that we've designed into whichever project they're needed in.
So delivered to actually work in the commercial world, or could be in racing outside of Formula One, of course?
Yeah, I mean, we don't do masses within racing at the moment. I think there's the main project that is racing at the moment, or two main projects that are racing at the moment are the America's Cup with the Alinghi Red Bull Racing team, and then MotoGP, where we're looking at aerodynamics for the KTM MotoGP team, and then a whole host of projects that aren't racing focused.
So that's where land, sea, and air comes in. Obviously, sailboat racing on the sea. It's also called a sister business to Red Bull Racing. So there is an influence by Formula One into Red Bull Advanced Technology. So how does what's learned and done in Formula One impact what you do?
So yeah, I mean, Red Bull Advanced Technologies was formed in 2014 when Dietrich Mateschitz, the founder of Red Bull, he expressed the desire to see the wonderful Formula One technology being applied in the wider world. And so that was kind of the initial mission statement of the company. And then there's a number of us who've worked in the Formula One team for a long time. You know, I've been there for quite a while, and we bring a lot of knowledge of the methods and the processes that are used in the Formula One team, and then we can apply them out into the different projects. And really, it's the methodologies that we use on the Formula One car that are most relevant to what we do. So, for example, in aerodynamics, we're using the same CFD process to analyse the airflow around whatever the project happens to be, whether it be a bike or a push bike or a MotoGP motorbike. We're using the same methodology that we use on the Formula One car to do that analysis. And it's those tools that carry the technology over.
I guess, so you mentioned computational fluid dynamics, or if you got a racing boat or a bicycle or a race car, making sure it can flow through the air with the least amount of resistance is common.
Yeah, I mean, minimizing drag is a sort of fairly common target. And so, yeah, so we use CFD extensively on pretty much all of the projects.
Now, you started in Formula One with Jaguar, and that was over 20 years ago now.
Yeah, 2002.
2002. So you went from a structural analyst at that point to actually a chief designer. So how do you compare all those years working in Formula One to what you do now?
So I suppose some of the roles I had on the F1 team I see are absolutely directly paralleled, and people within my team now have those same roles. So, you know, the structures job that I started in, we've got guys working in Red Bull Advanced Technologies doing that exact job. On a personal level, I suppose as you progress through your career, probably the amount of engineering you do versus the amount of general managing you do, the balance shifts. And so, whilst I still call myself an engineer, I know that the majority of my time is actually spent away on non-engineering topics.
So your titles in F1, they like a structural analyst, chief designer, and now you said manager. So do you ever feel like, oh, I wish I was doing more engineering?
Oh, all the time.
Yeah.
And I actively get involved in the projects as often as I can, but it's just there's a few different things pulling me in different directions.
So of all the things that you do, what do you like the most?
Probably the engineering. Yeah, no, actually, undoubtedly the engineering. Seeing a problem that needs solving and being able to get your teeth into it, that's great. And also, I mean, I love when we have a new project and you're in that kind of blue sky thinking phase, and when you're then maybe doing some quick calculations to try to work out whether your thinking's going in the right direction, that's the really enjoyable part of it.
Well, you know, and that's one of the big differences actually in Formula One, because a Formula One car tends to be an evolution, right? It evolves somewhat. You use the previous year. Now, if there's a change in the regulations, that jump is bigger, but you don't very often get like that clean sheet of paper and say, oh, how are we going to make this race car? So if you're on a new project, complete something no one's ever done before, how do you get the people together in that brainstorming session to come up with ideas? How does that real creative part work? How do you manage that?
Well, I guess so. We've got a good team of people, and the people side of it is really core to that. Where you throw a problem out to the guys and say, so we've been asked to look at whatever it might be, and get people's input and their thoughts, and then really just start kicking ideas around, and then firming up on things. And then it pretty quickly comes down to, right, well, we've got a bit of an idea of where we want this to go. So now we need to actually run some numbers and start laying out some shapes on the CAD to actually work out what the thing might look like, and really build it up from there.
They say sometimes that when you're developing new concepts like that, it's almost better, instead of having the super genius, that has all the ideas, to have people with a lot of different experience working together. And you mentioned when you were listing the different types of capabilities you have, there's mechanical, there's electrical, there's software. Is that a big part of it? Getting, because sometimes a software person might come up with a neat mechanical idea. Who knows? Does that play into it?
Yeah, it does. I mean, I think it's also very easy to forget some of the aspects of the engineering that are absolutely intrinsic to the project. So, it's very easy to forget that, okay, so you want to have a mechanism that does something. Well, you're going to need electrical to supply power to it, and you're going to need software to actually control it.
They all work together too.
And they all got to work together. And these guys have all got a lot of experience. You know, quite a few of the team have been in Formula One for as long as I have. And so yeah, they bring experience from all these past projects, and you apply that experience to whatever the new challenge is.
So few people have 20 years of experience on the design side for Formula One. So like you said, from 2002 all the way through to 2020, you were working on the design side for racing. So during that time period, what do you think were some of the biggest developments, technological developments in Formula One that really drove the sport?
Well, the big project I was involved in. So first of all, we had a big project to do an instant shift gearbox. That was a long time ago. That was about the third or fourth Red Bull car that we were doing that, and that was a really interesting project. And then the big one, obviously, was the hybridization of the power unit. So first of all, KERS. I think we added in 2009.
And what is, if you could explain?
So KERS, so kinetic energy recovery system, and that was really putting a 60 kilowatt motor, so about 80 horsepower, and the associated battery and power electronics onto the car, with the idea of saving energy under braking and then deploying it later on to give the driver a boost. And that was actually deployed by the driver pressing a button on the steering wheel at the time. And that then led on to the change in engines that came in 2014, when we went to the V6 turbo engine from the V8. And the V6 turbo was a huge change for everyone because it was such a complicated beast in comparison to the relatively simple V8s that came before it. You got two hybrid systems on that turbo, one electric motor taking power out of the crankshaft, or taking power out of the rear
Which
axle.
you didn't have on the V8.
KERS was that on the V8, but it was a very small part of it. Mm-hmm. And then the bigger change was that you had the turbocharger with the electric motor coupled to the turbocharger to recover waste heat from the exhaust. And so yeah, that was the biggest change, I think, on the car spec. And then from an engineering perspective, I think I'd have to say that the growth in simulation and simulation capabilities is the biggest thing that's changed. I mean, I remember when I started, CFD was kind of a fairly sort of unproven technology, and there were maybe a couple of guys working on CFD. And now you see that CFD is like an absolutely intrinsic part of the aerodynamic development process. And similarly on the vehicle dynamics side, we've gone from having a small number of guys simulating the car and how the suspension setup works, how the car corners, to now we've built simulators and we test everything in the virtual world before we go to the track. Some of this has been driven by the FIA. So the FIA they've ratcheted down the amount of track testing we've been able to do. And so inevitably that's meant we've ratcheted up, first of all, what we do in the laboratory. So we do a lot of physical testing of the car away from the track. But then secondly, the actual simulation to go ahead of the physical testing.
And you mentioned aerodynamic simulation and really any kind of simulation. Anytime you can run something real quickly on a computer rather than on the track, takes less time, not as expensive, and moving all the equipment, the race cars, the drivers. But there's also limitations. I think the FAA also limits the amount of time you can actually do computations because these simulations have actually gotten so good.
Yeah, on the aerodynamic side, they limit the amount of CFD runs.
But otherwise, you can do as much
otherwise,
as
I think you can do as much as you want to, yeah. And it's really, Formula One is a development race, so the faster you can get through these iterations of a different component or a different system and under a different number of designs, and understand what is actually going to make the car go faster, then if you win that development race, that's how you get those parts onto the car, you go faster than the competition.
Well, you mentioned when the new engine came in, you're extracting energy, right? Trying to recover energy from the turbo, right? And also from you generate energy, I guess you could say electrically, right, with a generator from braking. And most people think, oh, it's a race car. Just put a big motor in there and go as fast as you can. And that is important. But it's not really about having a big motor, but it's about getting the most power that you can. And I guess that was a big engineering challenge. I mean, looking back, you know how it was solved. But I would imagine when you first said, oh, we're going to have to take power from the turbocharger, and we're going to have regenerative braking, and we've got to figure out how all this works together, and then the driver's going to press a button. I mean, that's a very, very complex system, getting all that to work together, I would think.
Yeah, it's incredibly complex system, and
can't explain it in 2 minutes, right?
Well, no, I was going to say I think it's it's fair to say that we struggled at the start of 2014. We were with Renault at the time. And the system was not as well optimized as perhaps it could have been, and perhaps others were. And so, yeah, it's a big challenge.
And that's interesting because all the other teams are facing the same thing. And a big part of racing, I would think, would be to take what you start off with, your best effort on the first one, and then evolve it as quickly as you can. And if you can evolve quickly, then I think that's how you can get in front and stay in front, which Red Bull's been able to do.
Absolutely. I mean, I think Red Bull have always been very good at winning the development race. So I think, you know, there've been a lot of years where we've maybe not come out with the fastest car for race one, but then it's rapidly become the fastest car as you move through the season.
I want to ask you one last question about your career, because sometimes people, I mean, even in my role at Siemens, people come up to me and say, "Oh, what do I need to do to get a job like yours? What do I need to do to become the technical director, right, at Red Bull Advanced Technology?" I'm sure you must get that question, even from new employees. And you've been through so many positions, and over a 9-month period, you went from a chief designer to technical director, chief designer in Formula One to technical director for Red Bull Advanced Technology. Quite a big move in 9 months. What advice would you give to someone that wants to make what do you got to do to in 9 months make a big career move like that? What's the secret?
I'm not sure there's any one secret. I mean, I think career paths in Formula One can be frustrating because there's no well-defined ladder that you have to try to progress up. It tends to be, you see the opportunities, and if they're right for you, you take them. And I think I've been lucky in my career that I've always been offered good opportunities to progress. I enjoyed my role as chief designer, and then was asked, would you like to go and run the Advanced Technologies division? And I thought, well, yeah. I would think at the time I'd been doing that job for about
maybe?
No, I've been doing the previous job for about 6 years, and so I was fairly getting comfortable maybe. And so a new challenge was a good thing.
I think you raise a good point is whenever there's going to be a change, there has to be maybe a little bit of anxiety. And even this one too, running Red Bull Advanced Technologies, and that, it's going to pull me away from engineering.
Yeah.
Right. But I guess you have to be willing to accept those changes and move
Yeah,
forward.
absolutely. And I think the other thing I always say to people is that actually a lot of the moves I've made career-wise have been sideways moves where you think, I'm going to go and do something different for interest rather than particularly worrying about my career.
And those add up, right?
And they add up, and they typically result in a better job in the future.
Certainly one of the benefits of having moved over to Red Bull Advanced Technology is to having the opportunity now to work on Red Bull's first commercial hypercar, the RB17, which is said to be optimized for the on-track driving experience. So there's a lot of influence from what was learned in Formula One into the RB17. I think one of the things that's really interesting is you name the Formula One cars. Oracle Red Bull Racing names their Formula One cars like RB16, 18, whatever, is on and on. But when from 2020 to 21, during the pandemic, it was the RB16A and B, and then you jumped to the 18, which then left 17 open. So there's a lot of heritage. Even the name, you could ultimately buy a commercial car that is named like a Formula One car. So first question is, how does the performance of the RB17 compare to your Formula One cars?
Well, it's so the RB17.
Or how will it compare?
How will it compare? I mean, it's still in the design process, but at the moment, the aim is for it to be very, very close to the performance of the Formula One car. I'm hedging my bets there slightly, saying it's going to be close. I think it should be as fast as a Formula One car, but I don't want to shout about that at the moment. It's going to have slightly more power than a Formula One car, so we're looking at around 1,200 horsepower overall from the engine and hybrid system. It's not going to be a lot heavier than a Formula One car. And
even though it has additional bodywork and everything.
Even though it has additional bodywork. And it's going to have more downforce than a Formula One car. I mean, the interesting thing with RB17 is it's not constrained by the regulations of Formula One. So we're able to use things like active aerodynamics to really get as much out of it as we can. And so I think we've said before, it's a bit of a Red Bull or Adrian Newey's greatest hits car where all of the good technology that's been used in Formula One in the past is getting put into the RB17.
I think what's interesting about what you just said is that we all think about, a Formula One car, it's the fastest race car in the world, of course. But it's the fastest race car based on the regulations that it has to conform to.
Absolutely, yeah.
So as soon as you change those regulations, it could be faster or different, certainly different. But you're making a commercial car that you can take onto a track. So when you were let loose, hey, no more regulations, is it mostly aerodynamics?
I suppose the big difference on the aero side is that we're able to focus on having a lot more aerodynamics down at low speed, and then we're able to use active aerodynamics to limit how much that aerodynamic load increases as the speed goes up. And we have to limit it because the tyres simply could not take
just
the
wear
amount of
out.
aero. Yeah, couldn't. So you have a tyre load limit, and you cannot exceed that. So we have to limit the aero at higher speeds. It's a bit like DRS on the Formula One car, except we have DRS on the front wing, the rear wing, and also in
So it's actually active?
Yeah, so it's active aerodynamic elements.
The driver doesn't have to press a button.
Driver doesn't have to do anything, no. And actually, there's been a big focus for the driver with this car of making it easy to drive. So it's not supposed to be, while it's supposed to have performance similar to a Formula One car, it should not need a Formula One driver to extract a good amount of performance from it.
Well, I was going to ask you exactly that is, like you said, it's going to have the performance of a Formula One car. You're going to make it easier, but I would bet that if someone, your ordinary driver, maybe that has a little bit of skill, right? Maybe has taken a car on a track or something like that. They sit in the RB17. They're not going to be as fast as Max would be, right?
Well, if they are, we'll give them a job.
Oh, could be a good way to interview for your next drivers.
No.
I guess when you have all that power and all that capability, obviously you consider safety during crash and all that. Do you also consider safety from a standpoint of making sure that when somebody gets in that car, they don't overdrive it and get themselves into trouble?
Yeah, absolutely. So, first of all, there'll be very much a program of simulator work for the...
Oh, really?
Yeah, so the customers will be able to come and drive the car in the simulator before they take delivery.
Okay.
So they'll get to experience it in the virtual world before they go on track. So that's the sort of first aspect of the driver training. And then there'll be a number of organised events where the drivers can bring their cars along, and we'll have professional drivers on hand to help them start getting the most out of the cars. And then we will also have, so we've got the passive safety systems that you mentioned, and it's going to be it's more like a Le Mans car in terms of its safety system, frontal impact, rear impact, that kind of thing, than a Formula One car, just because it's a more similar geometry of car. But then we also have active safety systems, so it does have ABS, unlike the Formula One car, and it can use the other active systems to also help the driver out.
What did you learn in trying to do this that said, oh wow, this is a great F1 technology. It's going to really make this commercial car so much better. And right now, the RB17 is for taking it on tracks, at least for now. But ultimately, did you learn anything about an F1 technology that you brought into an on-track car that you think could even make an on-road car ultimately someday, maybe, or maybe it's even a different on-road car?
I suppose, it's not quite answering the question, but there's quite a few things where we're trying to make the RB17 far easier to live with than an F1 car. So there's technologies that we're developing, so taking the Formula One inspiration and then developing those technologies so that it makes it easier to run the car and requires less onerous servicing, and makes it a bit more robust for customers to live with. And so I can see that there is a pathway there where you then end up with something that's suitable for road.
After all, you still got to bring it in for an oil change and
all
the things that you...
But you don't, a Formula One car, for example, at the end of every race, you've got a fairly long list of parts that you have to crack check to make sure that they're good to be used again. And that's after sort of 300 kilometres of race, plus maybe after 500 kilometres total. And obviously you don't want that on your track car.
Will the RB17 come with its own crew that you have at your fingertips there if you want
to? We're not supplying
no crew. You got to find your own crew.
No, and really the aim is for it to be able to be run with an absolute minimum of crew.
You mentioned really some steps in the buying process, which, okay, I'm going to purchase the car, I'm going to get simulation training, probably a real driver to, an experienced driver to show around the track. You're only going to make 50 of these, and I believe the price is around £5 million or so, is that right?
Five and a bit.
Okay. Why just 50?
Well, because we want to build the car in the way we know how to build cars. And by that I mean we want to use the same build process we use with the F1 car to build the RB17. So the F1 car very much gets built in small chunks. So if you take a gearbox as an example, we'll build an oil pump. We'll sign that oil pump off on the rig, prove that it works. We'll do the same with the differential. We then put these parts together into the gearbox, we sign off the whole gearbox. And then when you put that gearbox onto the car and you go out on Friday practice, it just works and the car works. And we're using that same methodology for building the RB17. Also, we're not going to build these cars down a production line. We're going to have a team of mechanics putting each car together in a build bay like we do with the race car. So in order to use that process that we know and understand, we really have to limit the number that we're building. So we're looking at around 2 years to build the full quantity of 50. And I suppose we could have extended that, but we want to keep it exclusive. And we want to do it the way we know. And I think 2 years is long enough for that to be the case.
So should they call you if somebody wants to get on that list?
Yeah, absolutely.
Okay.
Absolutely.
All right. Adrian Newey, he was the creative force behind this. I think one of the things that's always fascinating about Adrian is he works on a drafting board. Few people still do that. Pencil, paper, big board. And I suppose that being able to work with a pencil and papers allows your creative juices, I would imagine, to come forward. But you're responsible not only to make a beautiful creative car, but one that works from an engineering standpoint. So I would imagine there has to be times when design and creativity has to be balanced against making it work from an engineering standpoint. How do you work with Adrian, and really, how do you balance the creative, the design aspects of a beautiful car with the functionality?
So I'd say that Adrian's design input is really on the actual functional aerodynamic side. We then have a couple.
Because that's the shape, right? The shape.
That's the basic shape. We do then have a guy on the styling side who tries to beautify the aerodynamic shapes and make them sort of work more coherently. And then Adrian and this other guy work together very closely to come up with something that's both beautiful and works aerodynamically.
And then you have to package everything else inside.
Yeah, I mean, that's another iterative process though. So, we go through, I don't know how many iterations of aerodynamic surfaces where we're then doing the mechanical.
You need to bump it out here or there or whatever.
That leads to sort of healthy conflict within the team where you've got the aero guys saying, no,
I like that healthy conflict.
Yeah, we want this to look like this, and the mechanical guys saying, but there's no space for these parts, and then they work together and work out a solution.
And I suppose then simulation becomes the arbitrator of all this.
To a large extent, yeah. I mean, we're very much performance simulation leads a lot of what we do. So every aspect of the car gets put into the model and run around the track. And if it makes the car faster, then we keep it. If it doesn't, then it goes. And a good example is the hybrid system, where the hybrid system is on the car because it is making the car go faster. No question about it.
Designing a commercial car is something Adrian's always wanted to do. In fact, that was a key part way back, I think, when keeping him with Red Bull. He said, you're going to get an opportunity to design a commercial car. And he worked with Aston Martin on the Valkyrie, which is quite the machine. And so he had his dream, or at least his dream on the commercial side, to develop this car. What did he learn from that you've improved on the RB17? What do you? How did that influence? What is it that he learned on that project that you've been able to take to the next level?
So yeah, I mean, Adrian and the whole of Red Bull Advanced Technology were very involved in the Valkyrie. It wasn't just Adrian. And I think the biggest lessons learnt really were the value of the R&D side of the project. So really, I think the Valkyrie maybe didn't spend as long in the test lab as it could have, and so then the track development phase took a lot longer than was intended. We're then trying to reverse that, so we were spending a lot more time in the lab running on the test rigs, so that when we hit the track...
That's the full car or components?
Well, everything from single component all the way up to full car. And it really trying to mirror the F1 process where we test the car so extensively on the different test rigs that you go to pre-season testing in Bahrain when you get 3 or 4 days on track. Everyone runs around. You rarely see a car stopping in pre-season testing these days.
Yeah.
And then you go to the first race and you go through the season with absolutely minimal issues. And so we're trying to copy that process and hopefully then have a much easier run through the track validation process and deliver a fantastically reliable car to customers.
I think that's really interesting what you just said about on that first practice day. It's a new car. It's an evolution of a previous year, say, more so or less so depending if there's rule changes, but it is a new machine. Like you said, because of simulation Now, on that first practice day, you rarely see the cars perform fairly well. I mean, maybe they're not at the ultimate speed and you've gotten every little tenth of a second out. How does that compare to what was going on, say, in 2002 or 2003? On that first, compare a practice day in 2002 to one and say, that we might see here in a few months when you start practicing.
Wow. I suppose back then there was very minimal testing of the car away from the track.
From simulation standpoint.
Yeah. And from physical testing of parts. So we used to test the safety critical parts, but that was about it. And so you'd go to the track and there was an awful lot of calibration work to do on the car when you first hit the track, and it was a fairly painfully slow process. And so I think back then I don't know the exact numbers, but we've probably gone from expecting to do sort of maybe a couple of 100 kilometres on the first track test day to being disappointed if we don't hit 500. But it's all because we've had to focus in on the value of track time because of the reduction of the track time that's available.
And that simulation is not just on the design of the vehicle, but the driver themselves.
Yes, I mean one of the really noticeable things is how infrequently we have to make a setup change when you go to a track these days. So years ago, every time you went to a track, the first thing you'd do after the first run would be to change an anti-roll bar or something else. And
the driver would come back and give you feedback.
And that was a fairly standard process. And now it's fairly rare to hear that happening.
Well, let's talk about other forms of racing. You've gotten together with Alinghi, I pronounced that right?
Yeah.
Alinghi, and you formed the America's Cup team with them. So Alinghi Red Bull Racing Team in America's Cup. And you've transferred knowledge that you learned in Formula One, another great example, into racing sailboats. So in what way do you apply, or what types of technologies from Formula One can you apply to a racing sailboat?
So with the Alinghi Red Bull Racing Team, we very much took the approach that we're not the experts in designing racing yachts. We're perfectly open about that. And so what we did with them is it's very much a partnership, where we've said to them, look, this is the technology we've got, this is what we can do. These are the tools we have, these are the methods we can use. And then we've let them pretty much pick and choose and say, well, we think it'd be really helpful if you can do this part for us or help with that. And so we've ended up then using the CFD process that we talked about to work on the hull design of the boats. I mean, these boats actually, you think it's going to be a hydrodynamic problem, but it's actually an aerodynamic problem because they spend...
Is that because of the speed of the boat? Or?
Well, no, just because they're foiling boats. They spend so little time actually in the
water. Only the foil's in the
Yeah.
water. So the whole body of the boat, the mass,
the whole
the
hull is more of an aerodynamic problem these days. So we've applied the same CFD process. We've then ended up designing an awful lot of the electrical installations on the boat, and I think we've done a pretty good job of applying the same rules that we use for Formula One design to make sure that it's a reliable installation, it's robust, it's easy to service, it's easy to swap parts out. It sounds like fairly basic stuff, but I think it should be fairly useful. And then probably one of the biggest areas we're involved in is on the control systems, because America's Cup's actually fairly free in terms of regulations on the control systems, certainly compared to Formula One. That's
I didn't know that. So you can have computers, or
you have control units, and you can write.
Are they making decisions on the placement of the sails?
Not so much decisions, but just because a lot of the controls for the sailors are done via electronic control modules, so human machine interfaces, and so they'll be pressing a button to make the sail move, and then it's how you then go through the system to actually make that happen, and how you link some of these functions together.
I'm not an expert on America's Cup sailing boats, but you see them with the cranks, and when you say press a button, are they still doing the cranking and all that, or is it now all motorized when you're making adjustments?
So the cranking is to generate hydraulic pressure within the system, and then and so the guy's cranking, and they're actually going to be cycling, or they're allowed to be cycling again in the next America's Cup, and so the cranking is generating hydraulic pressure, and then the guy who's trimming the sail, he presses the button, and that gives the command to actually use the hydraulic pressure to adjust the sail.
Oh, okay. So the humans are basically just creating a reserve of power that you can. Is the control system making the decisions of how much to trim and do all those things?
I don't think it's making the decisions. That's still down to the guy who's actually doing the trimming. But it's just that it's the actual. It's how that function actually happened, how you actually make things move.
When you're engineering something like the RB17, a Formula One car, safety is a big part, especially crash safety. On a racing sailboat, though, it's lower speeds. If you crash, you fall into the water, I guess. Now, I'm not trying to belittle it or not, but it's certainly not the same as going 200 miles per hour on a track where you might hit a wall. Does that allow you to design with less safety factor, maybe closer to the edge where you're eking out? In other words, safety is, relatively speaking at least, right? Maybe a little bit less of a concern so you can draw more performance out.
I think the problem there, though, is that so a Formula One car is a very well-defined problem in that, you've got the cars that, as you say, iterate slightly each year, and they go around the tracks that are fairly well known, and it's fairly well constrained, and so you've got a pretty good idea of the loads we're going to see on next year's car before the car hits the track.
Okay.
Whereas the America's Cup boat, it's kind of, well, the Alinghi Red Bull Racing guys are designing what they call Boat 1, which is the first own designed boat, having got Boat 0, which is a boat using a hull from an existing design. And so there's a lot more unknowns. And so rather than feeling like we're able to push the envelope because of the lack of safety requirements, it's more a question of being less certain over the loading that you're going to see and having to account for that. And the loads are huge. We've designed some parts of the boat that we're seeing more than 10 tons of load going into. And so where we've then tested these parts in the lab, it becomes really quite challenging to actually get that load into the parts.
Carbon fiber and composites play a big role in racing sailboats and race cars and all that. And composites are a unique material because you can tailor the strength and the stiffness in different directions. And they always say, well, one of the greatest advantages of carbon fiber is you can do all that tailoring. And then they say, one of the worst things about carbon fiber and composites is that, oh my God, we have so many options. How do we pick the right one? And I would think with a racing sailboat, like you said, you got the hydrofoils, it's lifting out of the water, you got these masts that are driving the thing forward, many, many meters up into the air. Is there a lot of tailoring that goes on to what the directions of the fibers are, or how you're placing the carbon fiber or the composites when you're designing a sailboat like that?
Yeah, I think so. It's we've not been responsible for the hull design itself, but on the components we have been doing, yeah, it's very tailored. Tailored.
And what components is Red Bull Technologies actually?
I can't really go into too much detail,
okay.
But there's quite a selection where we've seen it's really looking at this, the parts where we can see the Formula One the application of Formula One technology being particularly relevant.
Do you ever have moments where the boat guys say, "Oh man, there go those racing guys again," or vice versa? I can't believe these boat guys won't do that. Don't they understand? Or, do you ever have moments like that?
So my colleague on the Alinghi Red Bull Racing side, and I'm sure he won't mind me quoting him, Sylvia, he likes to remind me every so often. He says, "Rob, we're lumberjacks, you're watchmakers."
Oh, so it's a cross between a lumberjack, an axe, and a fine Swiss watch or something like that. Not quite sure what that ends up being, but it makes sense. Though it does make sense.
I think it's more just that occasionally, we're used to working on very, very small components in intricate detail, and then you look at some of the America's Cup parts, and just the scale of the thing is so much bigger. It's easy to when you're looking at on a CAD screen, it's easy to forget that it's actually a 75.
Yeah, you need to put them side by side.
Yeah, exactly.